Ladies and gentlemen, the story you're about to see is true. The names have been changed to protect the innocent.
In November 2010, a team of elite investigators from around the world was summoned to Punta Arenas in southern Chile. Their mission? Investigate rumors that the notorious and voracious king crab were beginning to invade the Antarctic continental shelf, one of the most biologically productive areas on Earth. Because of the effects of glacial ice and a deep-water current called the Antarctic Circumpolar Current, the water on the Antarctic continental shelf is colder than the deeper surrounding water. This colder water has until now kept the king crab from leaving the warmer, deeper water and climbing up onto the Antarctic shelf. But now, the water temperature has started to rise, and there were fears that the king crab were already moving up towards the Antarctic shelf. If they reached there, they could devour and destroy the unprotected indigenous communities of starfish, sponges, anemones, and sea cucumbers, changing the ecology of Antarctica forever. The investigative team's base of operations was the Nathaniel B. Palmer, a research icebreaker operated by the United States Antarctic Program. The plan was for the Palmer to take the team from Punta Arenas across the infamous Drake Passage to Marguerite Bay in the Antarctic Peninsula, one of the most northern parts of the Antarctic shelf and a likely site of an initial king crab invasion. The Palmer could deliver the investigative team to the right location on the surface, but the team still needed something to allow it to see what was happening on the sea bottom. For that, Special Agent John Bailey brought his sea sled, an ugly but rugged underwater camera platform that could be towed slowly over the sea bottom, taking pictures. To take satisfactory pictures, Sea Sled had to be towed at a height of about 6 feet over the sea bottom. But even if Sea Sled could be kept at that range 100% of the time, it could still photograph only an 8-foot wide strip of sea bottom. The chance of picking just the right 8-foot strip where the king crab might be would be like finding a needle in a haystack. The Palmer left Punta Arenas on a beautiful Friday evening, the day after Thanksgiving. The team finished assembling Sea Sled, planned its initial search strategy, and set up its operations center in the Palmer's aft control room. The good weather that bid the Palmer farewell in Punta Arenas did not hold. By the time the Palmer passed the southern tip of Argentina and headed out into the Drake Passage, the sun had given way to clouds and wind. The sea became rough, and the ship started rolling with the building swells. The Palmer left the Drake Passage and entered the top end of Marguerite Bay on Monday evening, November 30th. The seas did not calm down as expected. Instead, it began snowing, and the ship was buffeted with high winds and 15-foot swells. If the large swells persisted, the rising and falling seas would make it impossible to keep Sea Sled close enough to the seafloor to take photographs and still keep it from hitting bottom, which could damage or even destroy Sea Sled's cameras or other instruments. By Wednesday morning, however, the seas had calmed down. Although it was still snowing, the swells were down to a just about manageable 6 feet. The search strategy chosen by the team's leader, Sven Thatche, was to tow Sea Sled across the slope of the Margaret Bay Shelf in a zigzag pattern of transects, the first transect going straight down the slope, the second going back up and diagonally across the slope, the third going straight back down the slope at the end of the diagonal transect. If king crab were on the slope, this search pattern should provide the best chance of locating them. The Palmer reached the beginning of the first transect on Wednesday, December 1st. With the help of the Palmer's crew, the team hooked Sea Sled to the Palmer's winch and A-frame and launched Sea Sled on its first mission. Although the high-quality photographs taken by Sea Sled's cameras could only be downloaded when Sea Sled returned to the surface, during a mission, Sea Sled sent lower-quality images and navigation data up the cable to computer screens on the surface. As Sea Sled was being lowered to the bottom, the investigative team kept their eyes glued to the computer screens, waiting for the first images to appear. Finally, after about 15 minutes, they did. The first pictures from the top of the Marguerite Bay Shelf showed a gray, gravelly sand bottom, with here and there communities of white brittle stars, orange sea stars, white sea anemones, and occasional fish. There were no signs of any king crab. Sea Sled reached the end of the shelf and began descending the Margaret Bay slope. Outside, the seas calmed down, and the Palmer was visited by a group of curious penguins. The bottom dropped off quickly as Sea Sled descended the slope. If any king crab had begun to scale the slope, this is where they would most likely be found. The investigative team kept their eyes glued to their computer screens as Sea Sled moved down the slope. The populations of brittle stars and sea stars started to dwindle. Then, after almost 4 hours, it happened. There, smack in the middle of the computer screens, was the unmistakable bright orange image of a king crab. There was no longer any doubt. King crab had definitely begun making their way up the slope towards the Margaret Bay shelf. At least this one had. Were there more? The answer came quickly. Less than a minute later, a second king crab appeared on the screens. A few minutes later, another. All told, by the time the Palmer reached the end of the first transect in the early morning hours of December 1st, the investigative team had spotted over a dozen king crab in the low-quality images sent up by Sea Sled to their computer screens. Sea Sled had now been underwater for over 6 hours. Rather than waste time bringing Sea Sled to the surface to download the high-quality images stored on board, the team decided to keep Sea Sled on the bottom and continue straight on along the second and third transects. The second transect produced fewer king crab pictures than the first. Still, the team spotted another 10 king crabs on the portion of the second transect that crossed the bottom half of the Marguerite Bay slope. Things changed dramatically on the third transect. Even though the third transect was similar in length and location to the first two transects, the team spotted nearly 3 times as many king crabs in the images sent up by Sea Sled. Fortunately, again, they found no king crabs on the upper half of the slope or on the Antarctic shelf itself. After almost 20 hours in the water, Sea Sled was lifted back on board the Palmer in the evening of December 1st. The over 50 king crabs Sea Sled had located in the very thin strip of sea bottom photographed by Sea Sled's cameras far exceeded what anyone had anticipated. To put these numbers in perspective, the total area of the lower half of the Margaret Bay slope photographed by Sea Sled's cameras in the first 3 transects was about 250,000 square feet. There were 50 king crab in those 250,000 square feet, which is an average of 1 king crab for every 5,000 square feet. That doesn't seem like much until you realize that the total area of the lower half of the Marguerite Bay slope is more than 3 billion square feet. At an average of 1 king crab per 5,000 square feet, that meant that a potential invasion force of well over 500,000 king crab was moving up the slope towards the Marguerite Bay shelf. The team needed to know whether the average density of king crabs found along the first 3 transects held true for the rest of the Marguerite Bay slope. Working in shifts, the team did 5 dives with Sea Sled over the next 4 days on different parts of the Marguerite Bay slope and shelf. Their findings from those 5 dives were even more alarming than those from the first. Not only was the density of king crabs on the lower part of the Marguerite Bay slope even greater than in the first 3 transects, but the team for the first time spotted king crabs on the upper part of the slope, only a few hundred meters from the shelf itself. But even more disturbing was the discovery made by the team while going through the higher quality images downloaded from Sea Sled after the dives were completed. In 3 separate incredible images, juvenile king crabs could be seen assaulting starfish several times their size. The king crab attack on the Antarctic ecosystem was not just imminent, as the team had feared. It has already begun.
Are we on camera?
Not yet.
It's not gonna make us look fat, is it?
Don't worry, you'll both look fine.
Aren't people gonna think that it's strange that we're talking without moving our lips?
No, everyone knows penguins communicate telepathically. Now, get ready, and action!
Hi, my name is Skyla, and this is my friend Zoe.
We're penguins!
Of course we're penguins. Everyone can see that. Anyway, the director asked us to tell you what we think about the king crabs that are about to invade the Antarctic shelf.
We're scared!
Of course we're scared. If the king crabs start attacking and eating the sponges, starfish, and even octopi that live on the shelf, it will disrupt the whole Antarctic ecosystem and food chain.
We'll starve!
Probably, but it's not just about us. Scientists have discovered that the unique plants and animals that live in the Antarctic shelf secrete substances that could fight cancer and other diseases in humans. Those would be lost too if the king crab make it onto the shelf.
Hey guys, come quick! Harry found a swarm of krill on the north side of the floe, and a bunch of us are hurrying over there to feed.
I love krill. Come on, Skyla, let's go.
You guys go ahead. I'll be there in a minute. I'm not a scientist, so I don't know why the water is getting warmer, but if there's anything you can do that would keep the king crab away, we would appreciate that very much.
Skyla, come on.
Okay, I better go feed, while I still can. Coming, Zoe!